k from there to there. But let me work without considering that. Okay, can I do that? Alright. So I'm going to say let 2 theta minus let it equal to some k. So I have 10k equals to negative 1.57. And I know that k tangent is negative in the second quadrant. So it's going to be 180 minus theta. Good. So let me find out k. Give me the reference angle, please. So what is our reference angle? Inverse 10 of that. Inverse 10 of 1.57 in degrees because it's given to degrees. Give me 4 decimal places if it's not exact. You calculate the degree mode 57.5. 57.505. Give me one more. 2. I don't want to work with rounded answers. Alright, so let us have our general solution. In the second quadrant, our graph, which is this stuff here, I'm going to write 2 theta minus 78 equals to, you see what I did? In the other ones, it's just theta over 2 or whatever, right? Equals to 180 minus 57.5052, then plus 360n because it repeats itself after 360 degrees. Alright? And in the, what quadrant is it? In the fourth quadrant, it's going to be 2 theta minus 78 equals to 360 minus 57.5052 plus 360n. That's theta. Let's simplify this part first. What is 180 minus that? 122.4948 plus 360n. Then what I want you to do is I want you to add 78 to both sides. I'll do this one last. Yeah. But that is becoming something. Okay. Did you add 78? Right. The problem is if you add 78, you can't add 78 there because it becomes a sort of a, what do you call it? A what? Good. But in order for me to get rid of this, I must add 78. You follow what I'm saying? So it's just going to be, even if I put this in bracket and I'm adding 78, I can only add the 78 to the 122. So add the 78 to the 122 point blah 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 blah. 200.448 plus 360n. Now divide those answers by 2. So theta will be 100 point something. 2474 plus 180. Then general solution. We are now going to put our values to see if our answer will be more or less within that given domain. So let us just screen this one as well. So what is 360 minus 57.5052? 302.49. Then divide that answer by 2. Add 78. So you're going to add 78 then. Okay, you get the idea? Give me after adding 78 to this answer. 380. Then divide that answer by 2. What is the answer divided by 2? 190. obviously 2 goes here. General solution.
Because if you put a 1 there, it will be less.
Right. So we expect quite a lot. How many answers? 1, 2, 3, 4 answers. Okay. So let's start with n equals to 0. And the reason why I'm going to use n equals to 0 is because 100 and something will be part of my solution. It will fit in my domain, my original domain. Okay. So if n is 0,
100.
then theta will be 100.2. If n is 0 here, it will be 190.2. So it fits within my domain. I'm just a little bit skeptical here. If I put 1 will be fine. Put n equals to 1. The answer here will be what? So there's no need for me to go n equals to 3 there, because it will go outside my domain. Huh? So these two solutions are fine, this one is also fine. If you put 2 here, you're also going to go way over. Do you see that? Do you see that? Now here's something I want to introduce to you. We tried 0 already. We know that 1 won't make sense because 180 plus 190 is already above 360, it's 370 something. Eh? Right. Put n equals -1 here into the general formula. So that means I'm going to subtract this from that. So I get about 10 point something. Good. So theta will be 10.2. How many solutions are there in your book? If I put -1 here, then this will then give me a negative answer. We're not dealing with a negative angle. Our domain was initially from 0 to 360. Yes?
But then the domain changes.
The domain doesn't change.
It's just
The domain is given to you. The solutions you are looking for, eventually, for theta, must fit within this domain. The only reason why they do that in the book is they're trying to lap that, like the way you understand what I did with the curves. But I'm saying, you don't need to do that, people, if you know the general solution. You follow what I'm saying? You don't really need to do that. So, that's why I was saying, try that, and I was like, the hell with it. I'm just going to take that whole business, not just the 2 theta, to equilibrate. Are these not your solutions in the example? Are these not the solutions in the example? Even try to look at the example. That is right there. Do you see that? 4 solutions. And if I'm not happy and I still get, so you need to be able to look at your general formula and then see to yourself, wait a minute, what happens if I put 0, 1, 2, -1, perhaps a little bit like that. Especially when, if you add this with that, you realize you're getting a big number. What if this number is bigger than this number in terms of it being 1? Put a negative here so that you can clearly subtract. You see that? Then you get those solutions. Now we're going to try the same thing. We're going to do one question. Exactly. So general solutions, very powerful. Stop the head.
this one is
You can use this method to solve any of the solutions.